Welcome to Magic Numbers and Constants. So we're going to talk about what a magic number is, why it's a good idea to avoid them. We're going to use something called const expr, constant expression, and I'll explain how that works, briefly introduce you to coding standards, and then if you want to link, by the way, to the Unreal Engine coding standards, it's in the slides, but also just Google for Unreal Engine coding standards. And then we're going to actually use one of these constant expressions for our word length. And at the end of it, what will happen is we'll have a bit in our code like this that says word length equals, and whatever we put will be taken through to the code so that we have a single place in our code where we constantly refer to this word length, but we can change it in just one place. Okay, cool. So let's dive in and make this happen. Okay, so I want to finish introducing this game. So I'm going to say, welcome to Bulls and Cows, a fun word game. Oh, fantastic. All right, now, next line. You can put what you like here, but I'm going to say something along the lines of, can you guess the X letter isogram? We'll come back to the X in a minute. I'm thinking of question mark, and then maybe a \n this time, just to show that you can use either. Okay, so what does that give us? Well, let's run it and see. It's very simple. It just says, can you guess the X letter isogram? Now, X isn't very helpful. It's tempting to come in here and just hard code, because this version of the game is just going to have a single word in the dictionary, hard code 5 or 6. But I want alarm bells to ring in your mind whenever you write a number that's higher than 1. So 0 and 1 can be okay in a program. Anything higher than 1, like 2 and above, generally, unless you're using something literal like Route 66 or an A14, the road name in the UK, unless it's actually kind of literally in the world part of the name of something, try and avoid magic numbers, just numbers that you've plucked out the air and popped into your program, because they can be very hard to change. What we want is a mechanism to change the length of this word anywhere in the program, and that mechanism is going to be using something called a constant expression. Okay, let's try and put my tongue in. CONSTEXPR. That's a constant expression. Now, there's something else called a constant right above it, and we'll talk about those later. But we want to make heavy use in Unreal and C++ of things like constants and constant expressions. Whenever something doesn't change, we're going to use one of these two. For now, we're focused on constant expression. And a constant expression means that this thing can be evaluated right now at compile time. We know the expression from the very beginning. So the syntax is like this. Constant expression, then our name. Now I'm going to give it a name of word length for now. Word underscore length. Underscore's a safe way to separate things. Constant expression, word length. Now you need to immediately, and it's generally a good habit, whenever you declare something like this, when you say I've got a constant expression, it's called word length, let's give it a value, and let's say 5. Oops. Okay. That's great. All right, now, why have I done this all in uppercase, and what is it complaining about? Well, firstly, it's complaining because I haven't given it a type. You need to say what the type of this thing is. Constant expression, integer, word length equals 5. A normal declaration would not have this constant expression, but we want constant expression here. So what this is saying is I've got something I'm calling word length. Why all uppercase, by the way? Well, I've looked in Unreal's engine coding standards, and they don't seem to say anything about using constants, so I'm just going to go with all uppercase because it's a pretty common practice. We may change that later once we get in Unreal, but for now, this is representing, this thing does not change. It's got a value of 5. It's an integer, which means you can count it on your fingers, basically, if you've got a lot of fingers. And it's a constant expression, so it's going to be determinable right now as soon as I've written the code, and the compiler will be able to know what its value is right at the start. It cannot change once the program is running. All right, that's what constant expression does. And we want to use it here. So I've got a simple challenge for you. I want you to include this constant expression into your code. So I want you to include the word underscore length in the intro text and make sure it prints with spaces properly. You're just going to have to try and work out how that goes in there. It's using only syntax that you've used before. You're going to have to pop the expression word length into your code and maybe adjust things so everything fits on one line. So have a go at that, make a bit of a mess, play with it, see if you can get it printing out using word length so that if you change that word length, the text changes. So welcome back. Let's see how I'm going to do that. So when I get to the X in the X letter isogram, I'm going to close my quotes like that, and then I'm going to put another double chevron operator, and then I'm going to use word length. Notice how it populates for me. And I'm actually going to end the line there i.e. the statement, and I'm going to go onto a new line because I want to keep my code concise, and then I'm going to start again. All right, now, why does this work? It works because, well, let's see if it does work first, and then I'll talk you through why it works. Well, it doesn't, okay? I've got my spaces wrong, common error here. So I missed a space here. Now, what's going on? It prints out, can you guess the, and then a space, and then these spaces don't matter because the compiler ignores white space, but it doesn't ignore it when it's inside a quote. So I could get rid of these spaces. I'll do that as an example. Then it puts on the word length, and luckily for us, it converts from this integer thing here into a string. We're kind of taking that for granted, but it naturally does that for us. Then the statement ends, but it comes right along here and does another cout. And because we never ended the line with a new line, we immediately start to print. We put a space, which is the correction I just made, and then we carry on and put another new line. So let's just look at that working. There you go. Welcome to Bulls and Cows. Can you guess the 5-letter isogram? Now, if I change this constant here to, say, 9, you see it changes. 9. Fantastic. A small thing, but you'll see later why this really matters. Because word length is going to be used throughout our code, and there's going to be a load of stuff here, eventually, and we're going to want to refer to word length right down here, and there could be lots of references, so that we know if we only ever refer to word length like this, that if we change it, we can always change it in one place. You want to generally strive for having information in one place and one place only. I'm going to put my spaces back in here because they're ignored by the compiler. Only spaces within strings like this are actually make any sense. Also, other places that spaces make a difference are like using space namespace. We have to separate out these keywords. I can't just go using namespace. It doesn't know where one word starts and the other finishes, right? But I can go using namespace standard. If I really wanted to make my code ugly, I could put all sorts of weird spaces in here and it would still compile, but it would just look really horrible. Generally, never hit the spacebar more than once is a good rule of thumb. Okay, so I'm going to tidy up my code and we are done. We have learned a little bit about constant expressions. They're the strongest form of constant in C++, and you want to use it when you can.